All right, we're going to go ahead and we're going to start chapter 2 today. That is rational numbers. So we have talked about whole numbers. Those are the numbers that you knew before. And remember, those are all, so here we go, all numbers that are positive above 0, like 1, 2, 7, 100, and all of those numbers. Okay? Integers, so let's talk about those. We just got done with the chapter on integers, and don't forget, integers are all positive and negative whole numbers. So that would be like negative 100, negative 2, 5, 50, all of those numbers, okay? But now we're going to talk about something different, and those are rational numbers. Now, rational numbers are your numbers that can be written as fractions or decimals. Okay? Now, they can be positive or negative. So positive or negative. So if we write some examples, we'd be like negative 1/2, negative 0.3 repeating, and we'll talk about repeating decimals in a minute. Negative 1 1/3, 1 3/4, 0, here was one more, 0.7, okay? All right, so those are what our rational numbers are. So now we're going to go ahead and we're going to fill a chart in based on these numbers. Because realistically, we start with whole numbers, okay? So if we start with the whole number, so if we write it in here, and you guys should draw this too in your notes. Okay, so whole numbers, those are like 1, 2, 3, 8, 0, 100, and blah, blah, blah. Okay? Whole numbers can only be whole numbers. There's no other thing inside of whole numbers. They are just going to be whole numbers. Okay? But when we get to the next one, which is going to make more sense, when we start talking about integers, like we talked about in chapter 1. Okay, when we start to talk about integers, those are whole, positive, and negative numbers. But in this case, we'll talk about like negative 2, negative 10, negative 25, negative 752. Okay, so what it's saying is, and let me use a different color, these integers include everything that's inside of integers and everything inside of whole number because it's kind of encompassed together, if that makes sense. Okay, then we're going to talk about our last set. Our last set that we talked about, those were rational numbers. We've been talking about those already. These are the new ones. Okay, so those are our fractions and our decimals. We have like negative 1.2 repeating, because that's a repeating decimal. Again, I promise we'll talk about it. 3.5, okay? 2.7, negative 1/3. Okay? Now again, what this is meaning, what we're talking about here, everything is included here. So a rational number is an integer, is a whole number, okay? So when we talk about rational numbers, we can consider those integers and whole numbers rational numbers, okay? The only thing is when we can go inside, okay, like we just talked about, we just can't go outside, okay? So I can't say an integer is a whole number. I can't say -2 is a whole number. That's wrong, okay? So that's what that chart is supposed to make a little bit more sense of. Okay, let's go ahead and move on. All right, so we have two definitions now, a terminating decimal and a repeating decimal. A terminating decimal, I like to think about the terminator. So a terminating decimal is just simply a decimal that ends. So is a decimal that ends. Okay, so here's some examples over here. When we talk about money, generally those are decimals that end. If we have $5.25, okay, it does have an ending in sight. 0.5, that's a terminating decimal. It's over. There's no more numbers. Even if we had a number that was like 12.67824. Okay, it ends eventually. It doesn't say that it continues. So that's a terminating decimal. Let's go down to repeating decimals. Okay, so repeating decimals obviously are decimals that have a pattern that repeats. So it has to have something that repeats over and over and over again. So, for example, -1.18, repeating. Now, they can put the repeat sign over more than one number, or they can just put it over one number. In this case, this is over the 1 and the 8, so that means it's going to repeat. It's going to continue to go 1, 8, 1, 8, 1, 8, forever and ever and ever and ever, okay? So that's the whole purpose of the repeating decimal. Okay, let's try another repeating decimal. Look at this. So sometimes they'll have like 2.417. But let's say the 4 and the 1 are just 4 and 1, just the 7 repeats. So if the repeating sign is only over the 7, it's going to repeat the 7 over and over and over again. Okay? All right. So now let's go ahead and try to turn some of these fractions into decimals. While we're turning them into decimals, we're also going to see if they're terminating or repeating while we go through that. Okay, so in chapter 1, we talked about how this meant divide. That's going to be super important for what we're doing, for turning fractions into decimals. Another thing that's going to be super important, and I always write this in my notes, it's going to be inside over out. So everybody knows the movie Inside Out. So inside goes on top, or the top number's on the inside, so that number's going to be your inside number when you do your fraction. It's going to go inside the little square. And then your number on the bottom is going to be on the outside, inside out, okay? So now we can go ahead and we can start long division, which for some of us it may have been a while, but we have to do long division. So after your 1, you know that's a whole number. You would automatically just put the decimal up there because we don't want to forget it. That's the first thing I always do is throw the decimal up there, okay? Okay, so we know 4 does not go into 1. It just does not work. So we're going to put a 0 there, okay? And we know 0 times 4 is 0. That's 1, but we're going to add a 0. Drop it down. Now we have 10. Okay, 4 goes into 10 2 times. 2 times 4 gives me 8. So I'm going to do 10 minus 8, which is 2. Okay, again, I need to have another 0 because I'm not finished and we don't do remainders when we're in 7th grade. So drop down a 0. 4 goes into 20 5 times. 5 times 4 is 20. 20 minus 20 is 0. And that means that we have got it done. It doesn't have a negative sign, so that means it's just positive 0.25. And that's our answer. Okay, let's go ahead and do the next one. The next one, again, looking at it, like the one before, it didn't have a negative sign. This one does. I automatically know whatever my answer is going to be, it's going to be a negative, okay? I'm going to do my inside out. So my 1 goes on the inside, 5 on the outside. Automatically throw my decimal down there. Throw it up in the air. Okay, 5 does not go into 1, okay? I'm just going to add the 0 here in this case because we can do that, okay? I did it before because I wanted you guys to see that step. But we can actually put the 0 there. So I'm going to do 5 goes into 10 2 times. 2 times 5 is 10. And 10 minus 10 is 0. And there we have it. It's 0.2. But we don't want to forget, up here, it has to be a negative. So negative 0.2. And there's our answer. Great job. Okay, let's look at the next one. So we have 6 and 4. 6, that's weird because it's bigger, but let's see what happens. Okay? So 6 is going to be inside and 4. And don't forget, that's our negative because it's a negative. All right, so decimal, decimal. 4 goes into 6 one time. 1 times 4 is 4. 2 is your leftover. So bring a 0, drop it. And 4 goes into 20 5 times. 5 times 4 is 20. Subtract the 2, and you get 0. Now remember, we have 1.5 here, but we have to put it up where that negative is because your answer is going to be a negative 1.5. We can't just get rid of the negative sign. Okay, let's go to the next one. Okay, so we have 3 more problems, and we're going to work through these. So 5 over 11. 5 and then 11, okay? So we're going to start with 11 into 5. Obviously, that doesn't work, okay? 11 into 50. So it would go in 4 times. 4 times 11, 44, and 6 left over, okay? And dropping down a 0. 11 goes into 65 times. And 11 times 5, 55. And 60 minus 55 is 5. So I'm going to bring another 0 down. So now I'm getting to 11 goes into 50 4 times. 44. And that's 6. I can bring down another 0. But really, we should have saw the pattern right up here. So I had 50 here at the beginning, and now I have 50 again. As soon as I start getting the same number again, I need to consider whether or not it's a repeating decimal. In this case, it is. So we're going to do negative, or positive, sorry. Okay, sorry. You're going to have 0.45 repeating. And the 4 and the 5 are both going to repeat, so you're going to write it over that. Okay? Let's try number 4. So, inside out, 3, 11. So 11 goes into 3 0 times, so we'll make it 30. 11 goes into 30 2 times. 2 times 11, 22. Subtract them, you get 8. Bring down a 0. 11 goes into 80 7 times. 7 times 11 is 77. Subtract them, you get 3. Okay, I'm not even going to drop the 0 down because I see the pattern. I'm going to bring a 0 down. This is going to turn into 30 again, just like this. So we're going to repeat that. So it's going to be negative, because see the negatives there, 0.27 repeating. Okay? All right, good job. You go ahead and try number 5 on your own. All right, looking at problem number 5. Let's go ahead and look at it. There's a whole number here, 1. Okay, I'm just going to write that 1 point. And then something's going to go here after we figure out, we turn this fraction into a decimal. But we can deplete that 1 so we don't really have to solve for it. We don't have to divide it. Okay, then we're going to do inside out. So 27 divided by 5. Okay, so then we have 27 goes into 5 0 times. Okay, and then we're going to make this 50. Well, 27 is going to go into 50 one time, which is 27. All right, so we're going to have to 5, 4, and 10. Okay, subtracting. 10 minus 7 is 3. 4 minus 2 is 2. Okay, now dropping a 0. 230. So 27 goes into 230 8 times. 8. So 8 times 27 is 216. Okay? So 230 minus 216. So here's our minus again. And we're going to borrow 10, 4, and 1, 4. Okay, and we'll drop another 0. I hope I have room. I'm going to start writing smaller. So 27 goes into 140. Five times. 5 times 27 is 135. You have 5. So here we go, back with the 50 again, because you know that that's where it's going, right back into that 50. So here's our answer up here, and I'm going to get a different color so we can see it now. So it's 1, because that's our whole number, 0.185. It's all going to repeat, okay? All right, let's go ahead and look at a couple more. Let's go ahead and stop the video for tonight. We're just going to stop for tonight, and we will go over some practice problems in the morning. So I will show you the next slide, and if you want to do those problems tonight and we can go over them tomorrow morning, that would be fine, or tomorrow when you get to class. So here is the next set of problems. There are 4. You can try these at home if you want. Don't get frustrated. It's okay. We'll just go over them first thing in class tomorrow. All right? Thanks, guys. Have a great day.